Implicit differentiation. Sometimes we want to find the derivative of a quantity, but we do not have the explicit expression of the quantity. Instead, we have a relationship of the quantity with another quantity. So let's take a look at this example. Given x squared plus y squared equals 25, we want to find the derivative of y with respect to x. So how do we find the derivative? We need to use implicit differentiation to find this derivative. We need to keep in mind, okay, the function y is a function of x. And the function x, when you take the derivative, you just go as normal. So what do I mean by that? So to find dy over dx, okay, you need to take the derivative with respect to x on both sides of the equation. So this is just an operator, or you can simplify simply thinking that d over dx is just telling me to take the derivative. But you have to know it's with respect to x. So when it passes through x squared, term by term, derivative of x squared is just 2x. What about when it passes through y squared? Now, if you're talking about derivative of something square, it just take down the power decrease by 1, right? But because y is a function of x, you gain a factor according to the chain rule, dy over dx. That is the product of the chain rule, okay? Then it equals derivative of a constant is 0. Do not write 25 there. That is the implicit differentiation. Again, you do it term by term, and the key is the chain rule. Make sure you apply it correctly and understand when you gain a factor of dy over dx is when you pass through the y's. So now you can just solve for dy over dx. So you subtract x on both sides, right? 2x on both sides, so 2y times dy over dx equals minus 2x. Divide 2y on both sides, so dy over dx equals minus x divided by y. Now this is much simpler than solving for y. So okay, use this relationship x squared plus y squared equals 25. Then you solve for y, right? So y squared equals 25, subtract x squared. Then y equals plus minus square root of 25 minus x squared. Then you need to take the derivative with a more complicated expression. If you go that route, you should get the equivalent result provided you didn't make a mistake. But another problem is sometimes it's just impossible to solve for y. For example, if you have x squared plus xy plus y squared equals, let's say 1. It's just impossible. I mean, it still is a quadratic, right? So maybe you can say y squared, y cubed. It might be harder to solve it this way. So in a lot of cases, you cannot solve for y. And you must apply the implicit differentiation in order to find the answer that you're looking for.